By the 1990s, tens of billions of dollars of government funding in the US, UK and elsewhere were being diverted into research relating to global warming. A large portion of those funds went into building computer models to forecast what the climate will be in the future. But how accurate are those models? Dr. Roy Spencer was Senior Scientist for Climate Studies at NASA's Marshall Space Flight Center. He has been awarded medals for exceptional scientific achievement from both NASA and the American Meteorological Society.
Climate models are only as good as the assumptions that go into them, and they have hundreds of assumptions. All it takes is one assumption to be wrong for the forecast to be way off.
Climate forecasts are not new, but in the past, scientists were more modest about their ability to predict the weather.
Any attempt at forecasting changes of climate meets skepticism from the men who model the weather by computer.
In making decisions which affect people, a bad prediction as to what the climate of the future will be can be far worse than none at all. I'm afraid that our understanding of the complex weather machine is not yet good enough to make a reliable statement of the future.
All models assume that man-made CO2 is the main cause of climate change, rather than the sun or the clouds.
The analogy I use is like my car's not running very well, so I'm going to ignore the engine, which is the sun, and I'm going to ignore the transmission, which is the water vapor, and I'm going to look at one nut on the right rear wheel, which is the human-produced CO2. It's that, the science is that bad.
If you haven't understood the climate system, if you haven't understood all the components, the cosmic rays, the solar, the CO2, the water vapor, the clouds, and put it all together, if you haven't got all that, then your model isn't worth anything.
The range of climate forecasts varies greatly. These variations are produced by subtly altering the assumptions upon which the models are based.
The models are so complicated, you can often adjust them in such a way that they do something very exciting.
I've worked with modelers, I've done modeling, and with a mathematical model and you tweak parameters, you can model anything. You can make it warmer, you can make it get colder by changing things.
Since all the models assume that man-made CO2 causes warming, one obvious way to produce a more impressive forecast is to increase the amount of imagined man-made CO2 going into the atmosphere.
We put an increase in carbon dioxide in them that is 1% per year. It's been 0.49% per year for the last 10 years, 0.42 for the 10 years before that, and 0.43 for the 10 years before that. So the models have twice as much greenhouse warming radiation going in them as is known to be happening. It shouldn't shock you that they predict more warming than is occurring.
Models predict what the temperature might be in 50 or 100 years' time. It is one of their peculiar features that long-range climate forecasts are only proved wrong long after people have forgotten about them. As a result, there is a danger, according to Professor Carl Wunsch, that modelers will be less concerned in producing a forecast that is accurate than one that is interesting.
Even within the scientific community, you see, it's a problem. If I run a complicated model and I do something to it, like melt a lot of ice into the ocean, and nothing happens, it's not likely to get printed. But if I run the same model and I adjust it in such a way that something dramatic happens to the ocean circulation, like the heat transport turns off, it will be published. People say this is very exciting. It will even get picked up by the media. So there is a bias, there's a very powerful bias within the media and within the science community itself toward results which are dramatizable. The Earth freezes over. That's a much more interesting story than saying, well, you know, it fluctuates around. Sometimes the mass flux goes up by 10%, sometimes it goes down by 20%, but eventually it comes back. Well, you know, which would you do a story on? I mean, that's what it's about.
To the untrained eye, computer models look impressive, and they give often wild speculation about the climate the appearance of rigorous science. They also provide an endless source of spectacular stories for the media.
The thing that has amazed me as a lifelong journalist is how the most elementary principles of journalism seem to have been abandoned on this subject.
In fact, the theory of man-made global warming has spawned an entirely new branch of journalism.
You've got a whole new generation of reporters, environmental journalists. Now, if you're an environmental journalist, and if the global warming story goes in the trash can, so does your job. It really is that crude. And the reporting has to get more and more hysterical because there are still, fortunately, a few hardened news editors around who will say, you know, this is what you were saying 5 years ago. Ah, but now it's much, much worse. You know, there's going to be 10 feet of sea level rise by next Tuesday or something. They have to keep on getting shriller and shriller and shriller.
It is now common in the media to lay the blame for every storm or hurricane on global warming. But is there any scientific basis for this?
This is purely propaganda. Every textbook in meteorology is telling you the main source of weather disturbances is the temperature difference between the tropics and the pole. And we're told, in a warmer world, this difference will get less. Now that would tell you you'll have less storminess, you'll have less variability. But for some reason that isn't considered catastrophic. So you're told the opposite.
News reports frequently argue that even a mild increase in global temperature could lead to a catastrophic melting of the polar ice caps. But what does Earth's climate history tell us?
We happen to have temperature records of Greenland that go back thousands of years. Greenland has been much warmer. Just 1,000 years ago, Greenland was warmer than it is today, yet it didn't have a dramatic melting event.
Even if we talk about something like permafrost, a great deal of the permafrost, that icy layer under the forests of Russia, for example, 7,000 or 8,000 years ago melted far more than we're having any evidence about it melting now. So in other words, this is a historical pattern again, but the world didn't come to a crunching halt because of it.
Professor Siunishi Akasofu is head of the International Arctic Research Center in Alaska. The IARC is the world's leading Arctic research institute. Professor Akasofu insists that over time, the ice caps are always naturally expanding and contracting.
There are reports from time to time, a big chunk of ice break away from the Antarctic continent. Those must have been happening all the time. But because now we have a satellite that can detect those, that's why they become the news.
This data from NASA's meteorological satellites shows the huge natural expansion and contraction of the polar sea ice taking place in the 1990s.
Practically all the TV programs that relate to global warming show big chunk of ice falling from the edge of the glaciers, but people forget that ice is always moving.
News reports frequently show images of ice breaking from the edge of the Arctic. What they don't say is that this is as ordinary an event in the Arctic as falling leaves on an English autumn day.
They ask me, did you see ice falling from the edge of the glaciers? Yes. That's the spring breakup. That's happened every year. Press come to us all the time, you know, I want to see something that the greenhouse disaster. I say there's none.